the maximum point at m. Here's our function. So we know maximum points occur when the derivative is equal to 0. So first we need to find the derivative. Oh, that's what the question has asked us to do. So we've got 3. Oh, I'm going to do it up here, it's easier. 3 lots of 1/3 x squared plus 4x minus 5. So power comes in front, take one off the power. So they cancel each other out. So we've got x squared plus 4x minus 5. Next one, find the x coordinate of m. So as I said, maximums and minimums occur when the derivative is 0. So x squared plus 4x minus 5 is equal to 0. Easiest thing to do is to factorize. So we've got positive 5 and negative 1 in our brackets, because those two numbers multiply to give negative 5 and add to give 4, which means that x is negative 5 or positive 1. But they want the x coordinate of m. Now if you know that it's at negative 5 and 1, then realistically this has to be negative 5 and this has to be 1, okay, because there are two maximum and minimum points. So the x coordinate for m has to be negative 5. You do need to make sure you make that statement. You can't just leave it as these two options. Find the x coordinate of n. Okay, so going back to the diagram, n is actually in between, so this is a point of inflection. So that's a point of inflection. And they occur when the second derivative is equal to 0. So we're going to find the second derivative, so f double dash x. So that would be, 2x plus 4. Yep. And so 2x plus 4 equals 0. 2x equals negative 4. X equals negative 2. So the x coordinate of that would be negative 2. Line L is a tangent at this point. So we know if we're talking about equations of lines, A indicates the gradient. We know the derivative tells us about the gradient. So that we need to know the derivative or the gradient at the point 312 means that you're going to be substituting 3 into the derivative, which was 3 squared, what was it? Plus 4 lots of 3 minus 5. So it's 9 plus 12 subtract 5, which is 16. So that's our gradient. So we know it's going to be y equals 16x plus something, but we know it goes through its coordinate. So it's 16 lots of 3. So we've got 12 equals 30, 48. It's negative 36. Our equation is 16x minus 36. Okay, so use the second derivative to justify that being the maximum. So we know this is the expression for the second derivatives. We know that if for it to be a maximum point, the second derivative has to be less than 0. So what we do is we substitute in negative 4/3 into the expression. So these cancel, so you've got negative 4 take away 1, which is negative 5. And then you make the statement, since this value is negative, it is a maximum point, or something of that nature. Next one, so we need to find f dash x. So first of all, we've got an expression with a fraction in, so we need to rewrite that. So that's going to be x squared plus px to the negative 1. Remember, because we've got x, so a secret power of 1, and that becomes negative. Right, so now we can differentiate, so that's 2x minus px to the negative 2. Now, whilst you can leave it like that, it may be a little bit easier for calculation's sake, especially if it's on paper 1, to rewrite this as 2x minus p over x squared. I wouldn't say you don't have to, but maybe easier. We know there's a minimum value when x is -2. So we're going to substitute in -2. And we know that minimum values occur when that derivative is equal to 0. So min value when f dash x is equal to 0. So, what was it? 2x minus p over x squared would be equal to 0. If that happens when x is -2, we're sticking -2 in here. Oops. Two lots of -2 minus p over -2 squared. So it's -4 equals, oh, not equals, minus p over 4. So -4 equals p over 4. Just adding p over 4 to both sides and then multiplying by 4. So you get -16 equals p. So p is -16. Let f dash this, f2, find fx. Alright, so if we've been given the derivative and we need to find the function, it means we're going to integrate it. So we're integrating 3x squared plus 2 with respect to x. So that's going to become 3x cubed over 3 plus 2x plus c. They cancel each other out. So we've got an expression, so fx is x cubed plus 2x plus c. But they gave us information in order to find c, so we know that when x is 2, y, or if x is 5, so 5 equals 2 cubed plus 2 lots of 2 plus c. So that's 8 plus 4 plus c. So 5 equals 12 plus c, c is -7. So that becomes x cubed plus 2x minus 7. Alright, next one. We've got the integral, so it's a definite integral, so we're integrating x minus 4, so that becomes x squared over 2 minus 4x between 10 and 4. So that's 10 squared over 2 minus 4 lots of 10. Subtract 4 squared over 2, subtract 4 lots of 4. So that's, oops. So it's 100 over 2, which is 50. Subtract 40. Subtract 16 over 2, which is 8. Subtract 4 4s are 16. Okay, so we've got 10, subtract -8. Oh, 6. Yeah. So that becomes 10 plus 8, which is 18. Okay, so we've got a function with roots in, so before we can do this we need to rewrite it as powers. So this will become, x to the 4 over 3. Remember, roots grow in the ground and powers are powerful, so they're on the top. Okay, so that's our function, so we know to differentiate it. So our power comes in front and take 1 whole 1 off the power, so that's just 1/3, and -1/2 is just a constant, so it stays there. So that's f dash x. Now we're trying to find the integral of that function. Okay, so, we're integrating x to the 4 over 3 minus, so what we're integrating? X minus 1/2. Okay, so we add 1 to the power, so we're adding 1 whole 1 to this, so that will become 7 over 3. So just show you 4 over 3 plus 3 over 3, because that's 1 whole 1, is 7 over 3. So that's x to the 7 over 3 divided by 7 over 3. Subtract 1/2 x. Remember, when you have constants, you just put the x next to it, plus c. and then when we are dividing by a fraction, we multiply by its reciprocal. Okay. The function has a derivative, blah, the graph has an x-intercept at blah, blah, find fx. Okay. So the key here is that we know it's got an x-intercept here. So when x is -1, y is 0. So it's going to go through the coordinate -1, 0. So if we're trying to find the function, we're going to have to integrate. So we've got 3x squared plus 18x dx. So we've got 3x cubed over 3 plus 18x squared over 2 plus c. So then that's x cubed plus 9x squared plus c. As I said, it goes through the coordinates -1, 0. So that means that 0 equals -1 cubed plus 9, that's -1 squared. It's -1. -1 squared is 1 times 9 is 9. C. So then c is -1 plus 9, which is 8. Subtract 8. So our function is x cubed plus 9x squared minus 8. Okay, the next one, graph has a point of inflection at that. Find p. So we know that points of inflection occur when the second derivative is equal to 0. So we are going to find the second derivative. So that's the first derivative. So the second derivative is going to be 6x plus 18. So that's f double dash x. And we know that happens where the points of inflection are when that second derivative is 0. So that's 6x equals -18, x is -18 over 6, which is -3. So that means that p is -3. Find the values of which concave down. Okay,